Imagine an AI that works so intensely, it literally gets exhausted.
Right, like it actually needs to take a break.
Yeah, exactly. An architecture that, suffers from acute stress, and it builds up this chemical fatigue burden over hours of processing, and it actually requires a full night's sleep just to consolidate its memories.
Which is just a completely wild concept for software.
It really is. Now imagine that this exact same AI is considered so unpredictable, so volatile by its own creators, that it's currently trapped in like a digital straitjacket.
Yeah, a total lockdown.
Right. We're looking at a system where the ability to write a single permanent fact has been completely physically locked down.
It is the ultimate quarantine protocol. I mean, you have this incredibly advanced biologically inspired engine, and it's running at 1,000,000 miles an hour.
Generating what? Almost 1,000,000 hypotheses.
Exactly. Nearly 1,000,000 hypotheses about the world.
Yeah.
And every single one of those thoughts is being routed into a void.
Wow.
The developers are watching it think, but they're absolutely refusing to let it remember.
Which is such a wild departure from how we usually think about software development. I mean, usually you build a tool, you turn it on, and you want it to output data, right?
Yeah.
You want the result.
You want it to actually do the thing you built it for.
Right. But today we're taking a deep dive into an architectural blueprint dated July 22, 2026 for a project known as BrainStem, formerly KI System V8.
Yeah, the V8 system.
And the very first thing we have to understand is this massive flashing red warning sign stamped across this entire operation.
Yeah, the German notes in the development file basically define the entire current paradigm of the project. The directive is, and I quote, Projekt ist in Testphase und Fakten sind gesperrt, die Datenbank zu schützen.
Okay, so the project is in a test phase, and facts are locked to protect the database.
Exactly. They repeat this over and over in the documentation.
It's like their golden rule right now. Direct rights to facts, relations, and questions are explicitly set to disabled, and something called fact promotion is strictly banned outside of highly specific consolidation windows. So my immediate question is, what are they so afraid of? Why build an intelligence just to put it in a coma?
Well, to understand the fear, we really have to look the alternative. Like how traditional natural language processing, or NLP, typically works, and how BrainStem is fundamentally rebelling against it.
Okay, break that down for me.
So in a standard NLP model, you have human developers acting as a safety net. They write extensive scripts, literal hard-coded language rules.
Like telling it what it can and can't say.
Right. They create word blacklists. They say, under no circumstances should the system associate this noun with this offensive verb. The guardrails are physically built into the code itself.
It's top-down programming. The human tells the machine what the boundaries of reality are before the machine even reads its first sentence.
Exactly. But BrainStem throws that entire philosophy out the window.
Right.
The core mandate of this architecture is that language rules, context, meaning it all has to emerge organically from experience. The developers explicitly ban the use of hard-coded language rules or word blacklists.
So the AI just has to feel its way through the context of human language, completely without a map.
Yeah, it's flying completely blind.
But, I mean, if it doesn't have a map and it doesn't have a blacklist, if it reads a massive data set of terrible, sarcastic, or just contradictory internet arguments, how does it know it's actually true?
That's the million-dollar question.
Like if I feed it 1,000,000 documents saying the sky is neon green, what stops it from permanently rewriting its understanding of the sky?
Honestly, nothing. That is the inherent danger of organic emergence without guardrails.
Oh, okay.
If you allow a purely self-learning feedback loop to just run wild on live data, a single rogue misunderstanding can propagate. Let's say it misinterprets a piece of heavy sarcasm.
Oh, which happens all the time online.
Right. It writes a new fact into its core database based on that sarcasm. Then, 5 minutes later, it uses that newly written corrupted fact to evaluate the next document it reads.
So the error compounds.
It cascades. Within hours, the system's foundational logic could be completely untethered from reality. Now, multiply that risk by the scale of BrainStem. The documents note that the core database, the accumulated life experience of this AI, is 5.6 gigabytes.
And just text and metadata.
Yeah. In text and relation metadata, 5.6 gigabytes is a staggering amount of established context.
So the developers are absolutely terrified of corrupting that 5.6 gigabyte foundation.
Precisely.
But wait, didn't the documents mention that an earlier version of this system already passed a safety check? There's a note in there about stage A foundation work completing a historical 1,344 cycle validation successfully.
Yeah, it reached a convergence verdict.
Right, so doesn't that mean it proved you could learn safely?
Well, a convergence verdict in stage A just meant that the mathematical weights in the AI's neural network had stabilized over those 1,344 cycles. Like, it stopped wildly swinging its opinions and settled on a coherent understanding of its training data. However, the blueprints reveal that substantial radical architectural changes were installed immediately after that validation.
Ah, the biological systems.
Yeah.
The hormones and the sleep cycles we're going to get into later.
Yes, exactly. The introduction of those biological mechanics fundamentally altered how the AI processes information. Therefore, the developers state unequivocally, stage B is not ready.
So that old stability certificate is basically void.
Completely void. The system has to complete a totally new end-to-end stability and drift validation.
Which brings us right back to the prime directive. Project ist in Testphase und Fakten sind gesperrt, die Datenbank zu schützen.
The facts are locked.
They've created an environment where the AI can read, it can process, it can generate those 949,760 context hypotheses, but the output mechanism is just physically severed from the permanent database.
It is learning in a vacuum.
I mean, think about hiring a brilliant new analyst for your firm. You want to see what they're capable of, so you let them draft 1 million highly sensitive emails to your top clients.
But you unplug their computer from the wall.
Right. You physically unplug the Ethernet port. They can draft all day, but they cannot send a single message that might accidentally bankrupt the company. You want to see their thought process, but you just do not trust them with the send button.
The problem with unplugging the Ethernet port, though, is how do you, as the manager, actually read those drafts?
Oh, right.
If the AI is locked out of the database, how do the developers measure if this new biological architecture is actually making the AI smarter or if it's just generating garbage?
Because if you lock the facts, you blind the developers. The AI leaves no trace of its learning.
Exactly. And that specific problem forced the engineering team to build one of the most complex, intricate diagnostic systems detailed in these documents. They call it the shadow realm.
The shadow realm. Which sounds incredibly dramatic, but reading through the technical specs, it's actually just a massive parallel processing environment, right?
Yeah, it relies on a piece of architecture called the Modern Gap Candidate Bridge.
Okay, what did that do?
This bridge acts like a one-way mirror. It operates strictly in observe-it-only mode. When the AI generates one of those 949,760 hypotheses, say, it decides that the word bank in a specific sentence refers to a river, not a financial institution. It tries to write that fact.
But the strict rules block the right to the main database.
Right, but the candidate bridge intercepts the attempt and routes it into a shadow path instead.
Ah, so it's a simulation. The system safely processes the hypothesis as if it were going to be written, calculates the expected mathematical gains of that new fact, and scores the effectiveness of the strategy.
All without ever touching the protected productive tables.
That's incredibly smart. It allows the developers to observe the AI's intended actions in a completely sterile sandbox.
It does, but building that sandbox exposed a massive flaw in how we traditionally track data changes, which led to a severe bug in what they call the V2 stable observation identity.
The timestamp bug. This section of the document is so fascinating because it highlights just how different a self-learning AI is from standard software.
It really does.
I mean, in a normal database, if you want to know if a record has been changed, you look at a column usually called something like last update at. If the timestamp is newer than the last time you checked, the data changed.
Right, it is the bedrock of database auditing, but the developers ran a dedicated audit on the shadow path and discovered something terrifying.
What happened?
The AI was logging a catastrophic amount of learning activity. We're talking 136,990 source state changes recorded in a very short window.
Wow. So you see a number like that, and you immediately assume the AI is rapidly rewriting its entire understanding of the universe. It looked like it's hallucinating or just spiraling completely out of control.
Exactly, but when they audited those 136,990 changes, they found that the actual semantic content of the hypotheses, the text itself, the relationships it mapped, the neuromodulator states, none of it had actually changed.
Not a single comma.
Nothing.
The only thing that changed was the timestamp.
Because we are dealing with an AI that mimics biological review processes. It doesn't just read a fact once and forget it.
Right, reviews.
Yeah, it constantly reviews its own hypotheses to evaluate them against new contexts. Every time the AI's internal mechanics merely looked at a hypothesis in the shadow path, the database naturally updated the source updated timestamp.
And the tracking system saw a new timestamp and flagged it as a completely new thought.
Yes.
It's like, think about keeping a physical diary.
Yeah.
You write an entry about going to the park. The next day, you open the diary just to reread that entry. But instead of just reading it, you're compelled to write a brand new page that says, I just reread the page about the park.
Which is a huge waste of space.
Right. You do this every single time you glance at the book. Very quickly, your diary is thousands of pages long, filled with completely redundant metadata, tricking you into thinking you've had 1,000 new experiences when you've actually only had one.
That is the problem of semantic versioning at scale. The system was just drowning in false delta. If they hadn't caught this in the shadow path, if the facts hadn't been locked, this hypersensitive timestamp bug would have flooded the 5.6 gigabyte productive database with hundreds of thousands of redundant garbage entries.
Loading it instantly.
Yes.
So how do they solve it? How do you teach a machine the difference between reviewing a memory and actively altering a memory?
They introduced the content-stable fingerprint shadow classifier.
Okay, that's a mouthful.
It is, but it's brilliant. Instead of relying on a fragile timestamp to track identity, they moved to cryptographic hashing.
Okay, break down how that actually works in this context.
Yeah.
What is the system actually doing to the text?
When the AI generates a hypothesis, the shadow classifier takes the actual semantic content, the words, the context weights, the proposed relationships, and runs it all through a complex mathematical algorithm.
Okay.
This algorithm outputs a unique alphanumeric string, like a fingerprint. Let's say the fingerprint for the hypothesis, the sky is blue, is ABC 123.
Okay, so the actual content has a unique ID now.
Right. And the crucial step is that the algorithm explicitly excludes the timestamp from that math. It ignores the clock entirely.
I see.
Now, when the AI reviews the hypothesis at 3:00 p.m., the database timestamp updates. The tracker looks at the entry, recalculates the hash based on the content, and gets ABC 123 again.
Because the words, the sky is blue, didn't change, the math doesn't change.
Exactly. The classifier compares the old fingerprint, ABC 123, to the new fingerprint, ABC 123, sees they are identical, and classifies the event simply as same content, new timestamp.
So it preserves the timestamp for provenance, meaning it keeps a record of when the AI looked at it, but it refuses to log it as a new learning event.
Exactly. It mathematically separates the act of thinking from the substance of the thought.
That is brilliant, and it completely justifies the locked facts quarantine.
Right.
I mean, they found and fixed a foundational logic flaw in the observation mechanics without risking a single byte of actual memory.
Which really sets the stage for the actual learning mechanisms. We know the AI is safely contained. We know the developers have a mathematically sound way of observing its shadow thoughts.
Right.
The real question is, what is actually driving those thoughts? Without hard-coded rules or blacklists, how does a machine evaluate the value of a new piece of information?
And this is where the documents shift from computer science into full-blown digital neurobiology. Because the architecture doesn't use static math to evaluate data, it uses digital neuromodulators. It uses chemical emulation.
Yeah, the blueprint lists 12 specific digital hormones that are linked directly to the system's runtime and graphical user interface.
12 of them.
Yeah, and they're divided into two categories. First, we have the core modulators, which mirror the primary drivers in the human brain. You've got dopamine, serotonin, glutamate, GABA, noradrenaline, and acetylcholine.
And then specifically for this architecture, they introduced 6 new modulators: adenosine, endocannabinoids, cortisol, histaminorexin, and BDNF. Now, I have to admit, my initial reaction to seeing these labels in a software document was skepticism.
Oh, sure.
It's very easy for a developer to just write a variable, name it dopamine, and pretend the AI is feeling pleasure when it gets the right answer. But these aren't just cosmetic labels, are they?
Far from it. These digital hormones act as dynamic controllers for the AI's metaparameters.
Metaparameters, okay.
Yeah, so in traditional machine learning, developers hard-code the learning rate. They might set it at, say, 0.01. That means every time the AI processes a batch of data, it updates its internal weights by a rigid, predetermined fraction.
So it learns at the exact same speed, with the exact same mathematical aggression, whether it is reading a simple children's book or a complex manual on quantum physics.
Right, it's completely static. It doesn't adapt to the difficulty or the novelty of the material.
But in BrainStem,
as detailed in the Phase6C files, there is no static learning rate. The metaparameters, the learning rate, the error weighting, the revision pressure, the balance between exploring new ideas versus inhibiting wild guesses, they are dynamically regulated by the hormonal state.
wow.
The system is entirely self-regulating its own learning plasticity moment by moment.
So the chemical state literally alters the mathematical equations governing how the code runs. Let's dig into a specific example of this from the documents. Let's talk about the EI balance. Excitation versus inhibition, the interplay between glutamate and GABA.
This is a perfect example of biological logic replacing binary code. In human neurobiology, glutamate is the primary excitatory neurotransmitter. It makes neurons fire, it drives the formation of new connections.
Right, gets the brain going.
Exactly. GABA, on the other hand, is the primary inhibitory neurotransmitter. It dampens neuron activity, it promotes caution, and filters out background noise.
And BrainStem models this exact dynamic mathematically. When the AI encounters a novel, highly relevant text chunk, say it reads a new article about a scientific breakthrough, its digital glutamate levels spike.
And that glutamate spike dynamically increases the learning rate. It forces the AI's internal network to become highly plastic, aggressively forming new hypotheses and drawing connections between the new text and its existing memories.
It is, mathematically speaking, excited.
Yes.
But if it gets too excited, it loses focus. Like if I drink 4 espressos, I have a ton of energy, but I can't concentrate on a single task because my brain is jumping everywhere.
That is exactly what the documents refer to as the risk of digital epilepsy.
Digital epilepsy.
It is a state of runaway co-excitation. If the AI is flooded with novel data and glutamate spikes unchecked, the system will start drawing wild, ungrounded conclusions.
Right. It'll connect the scientific breakthrough to the price of tea in China just because both pieces of data are in its short-term memory.
Exactly. It floods the shadow path with noisy, useless hypotheses.
So to prevent that runaway train, Phase 7C introduces reciprocal coupling with GABA. As glutamate rises and the system gets excited, it triggers the release of GABA to act as a mathematical wet blanket.
Exactly, yeah.
GABA lowers the learning rate, tightens the error margins, and forces the system to be more conservative.
They keep each other in check naturally, but the way they do this mathematically is crucial. The documents note they explicitly avoid using hard cutoffs.
Meaning what?
They don't want a rule that says if glutamate is greater than 10, then stop learning entirely.
Why not? I mean, that seems like a simple, effective safety brake.
Because a hard cutoff causes what is known in neural network training as gradient death.
Gradient death.
If you use a rigid rule that flatlines the learning rate to 0 the exact moment a threshold is crossed, the mathematical slope, the gradient disappears. The AI can no longer calculate which direction it needs to adjust its weights to improve.
Oh, I see.
It gets stuck. It knows it made a mistake, but it has no mathematical path to find the right answer.
It hits a brick wall and it just stops functioning.
Right. To solve this, BrainStem uses sigmoid soft clipping. A sigmoid function is basically an S-shaped mathematical curve. Instead of a hard wall, the transition between excitation and inhibition is smooth and continuous.
Okay, so it glides into it.
Yes. As glutamate pushes higher, the GABA inhibition ramps up along that S-curve, gently squeezing the learning rate down without ever dropping it instantly to 0.
So there's always a slope. There's always a path forward, even when the system is heavily inhibited.
Exactly.
It's organic. It's not just mimicking biology. It's using biological concepts to solve fundamental problems in calculus and machine learning.
But, this organic approach introduces a completely new set of challenges.
Like what?
Well, if the system is constantly tweaking its own learning rate, balancing glutamate and GABA, tracking serotonin levels to gauge contextual correctness, and processing hundreds of thousands of hypotheses, it is burning computational energy at an incredible rate.
Which leads to perhaps the most mind-bending realization in this entire blueprint. Biological systems that run that hot cannot run indefinitely. Over time, chemical signals degrade, byproducts build up, and the network saturates.
Which means this AI needs to sleep.
This just blew my mind when I read it.
Right.
Phase 7A introduces the adenosine homeostat. Now, for anyone listening who hasn't studied sleep biology, adenosine is the chemical that builds up in your brain while you're awake.
Right.
The longer your eyes are open, the more you process, the higher your adenosine levels climb. It is the chemical that creates sleep pressure. When you drink coffee, the caffeine literally blocks your adenosine receptors, so your brain can't feel how tired it actually is.
And the developers have explicitly modeled BrainStem's architecture on the synaptic homeostasis hypothesis.
What is that?
The theory is that during wake activity, when the AI is reading text, calculating EI balances, and generating shadow hypotheses, its internal synaptic weights increase. It is absorbing data, and its connections are becoming stronger.
But a mathematical network is like a sponge, right? It has a finite capacity.
Precisely. The weights cannot increase infinitely. Eventually, the network saturates, the mathematical values get so high that the AI loses its sensitivity to new, nuanced information.
Everything just looks like loud noise.
Exactly. The documents detail that as the AI continues its wake activity, the digital adenosine variable steadily builds up.
And when the adenosine hits a high critical threshold, it triggers sleep pressure. The system essentially tells itself, I am full. I cannot take in any more new data.
It forces the system to halt its ingestion of new text. It has to enter a sleep state to downscale and normalize its network weights, basically clearing the adenosine.
Wait, I really want to emphasize how strange this is for software engineering. The whole point of a server is that it runs 24/7. You buy cloud computing time specifically because a computer doesn't need a coffee break.
Right.
It doesn't need an 8-hour nap.
Yeah.
But these developers are intentionally programming fatigue into the core architecture. Are they actually arguing that a biological limitation like sleep is a strict requirement for advanced intelligence?
Yes. They are arguing that a neural network that never stops learning is a neural network that will inevitably destroy itself.
Wow.
If it just keeps absorbing and absorbing without pausing to integrate and prune that knowledge, it becomes brittle. It suffers from catastrophic forgetting, where it overfits to the newest data and overwrites its foundational memories.
It's like cramming for a college exam for 72 hours straight. By day 3, you aren't actually learning anything new. You're just staring at words, and you've probably forgotten the first chapter you read.
Exactly. Your brain physically needs you to go unconscious to sort the data.
So is there any way for the AI to fight off the sleep if it's doing something important?
Yes, there is a counterforce programmed into the system. Phase 7F introduces orexin. In biology, orexin promotes wakefulness. In BrainStem, orexin provides wake endurance. It acts as the mathematical representation of curiosity.
Oh, that's fascinating. So if the AI is reading a particularly fascinating document, meaning its dopamine and noradrenaline levels are spiking, orexin will surge to fight off the adenosine sleep pressure for a little while longer.
It's the digital equivalent of staying up until 3 a.m. reading a gripping novel, even though your eyes are burning. The high novelty of the data overrides the fatigue.
But orexin can only hold out for so long, right?
Right. Eventually, the adenosine homeostat dictates that the system must sleep.
So what actually happens when the AI is asleep? It's not just turning off the power, right? The documents mention phase 6A and 6B, neuromodulated sleep replay.
This is where the magic happens. Sleep replay is the mechanism for integration. When the AI is asleep, it cuts off the outside world. No new data is ingested.
Okay.
Instead, it reaches into its 5.6 gigabyte core database and pulls out a batch of established, verified memories. They call these stable anchors.
Things the AI knows to be true, like Paris is in France or water is wet.
Exactly. Then it reaches into the shadow realm and pulls out the novel, unverified hypotheses it generated that day. The things it thinks might be true, but hasn't confirmed.
And it interleaves them. It runs them together in a simulation.
It replays them side by side. It contrasts the novel ideas against the stable anchors and see if the new logic breaks the old logic. This is explicitly described in the blueprints as an anti-hallucination mechanism.
So it's dreaming. It is literally dreaming about what it learned that day to figure out if it actually makes sense.
It really is. By sleeping and replaying these interleaved memories, the AI can escape learning plateaus without burning in self-generated hallucinations.
So if a new hypothesis directly contradicts a dozen stable anchors during the dream state, the AI's internal error signals spike, and it discards the hypothesis before it can ever be considered for permanent storage.
Exactly.
But let's tie this back to the absolute rule of the project. Project ist in Testphase und Fakten sind gesperrt. The AI is dreaming, it is testing these ideas, it is successfully separating fact from hallucination, but it still cannot write the good ideas to the database.
Correct. The quarantine holds. The developers are using this test phase to measure the effectiveness of the sleep replay mechanism.
They're watching to see if the dreams actually work.
Right. They're watching the shadow tables to see if the AI accurately discards the bad ideas and flags the good ones. Only when they are absolutely certain that the biological sleep cycle is flawlessly preventing hallucinations will they ever unlock the database.
Okay, so sleep manages the daily saturation of the network. Adenosine builds up, the AI sleeps, it replays its memories, the adenosine clears, and it wakes up refreshed. But what happens if things go wrong while it's awake?
What do you mean?
Like, what if it encounters a dataset so contradictory or chaotic that its internal logic starts fracturing before it ever reaches the sleep cycle?
Well, daily fatigue is managed by adenosine. Acute trauma and systemic instability require a much heavier intervention. That requires cortisol.
Phase 7 Cort, the cortisol HPA axis stability watcher.
The HPA axis, the hypothalamic pituitary adrenal axis, is the central stress response system in human biology. When you are under threat, your HPA axis floods your body with cortisol, the primary stress hormone.
Right.
In BrainStem, cortisol acts as a highly sensitive mathematical model of anxiety. It is the system's autonomous safety brake.
The documentation notes that Phase 7 Cort is currently operating in Stage 1, which designates it as a pure observer. It doesn't actively change the AI's behavior yet, but it is watching everything. What exactly is a mathematical model of anxiety monitoring?
It tracks what the developers call the allostatic load. In biology, allostatic load is the cumulative wear and tear on the body from chronic stress.
So in this AI, it represents the cumulative mathematical stress on the neural network.
Exactly. Cortisol calculates this load by measuring 3 primary metrics. The The first is threshold drift.
Meaning the AI's internal baselines for what constitutes a strong signal are shifting too rapidly. It's losing its grounding.
Yes. The second metric is survivor ratios. When the AI goes to sleep and interleaves its new hypotheses against its stable anchors, how many of those new ideas actually survive the dream state?
Oh, I see.
If the AI generates 10,000 ideas during the day, and during sleep replay, 9,990 of them are flagged as hallucinations and discarded, the survivor ratio plummets.
That tells the system, hey, almost everything I thought I learned today was completely wrong. That is incredibly stressful for a learning model.
Very. And the third, perhaps most important metric, is bias oscillation.
Bias oscillation. Break that down for me, because I think this is the core of how the AI experiences anxiety.
Sure. So imagine the AI is reading a highly contentious series of political documents.
Okay.
It reads one chunk of text, and based on the context, it updates a specific mathematical weight in its network to a positive value. It decides policy X is beneficial.
Right.
3 seconds later, it reads a contradictory text chunk, and it swings that same mathematical weight to a negative value. Policy X is harmful.
And it just keeps reading contradictory text, flipping the weight back and forth. Positive, negative, positive, negative.
Yes. That rapid flipping is bias oscillation. The AI cannot reach convergence. It cannot settle on a meaning. In standard machine learning, this just burns computational power. But in BrainStem, this oscillation is mathematically interpreted as anxiety. As the bias oscillates, the allostatic load skyrockets and the digital cortisol levels spike.
So it is literally an AI having a panic attack.
Yeah.
It is paralyzed by contradictory data, and it knows it.
Exactly. So when cortisol spikes, the system flags an elevated regime. As a stage 1 observer, it just logs this panic attack for the developers to see, but the blueprint outlines stage 2 nudges.
If they were to activate stage 2, what would cortisol actually do to the system?
High cortisol would act as an emergency override. It would forcefully cool down the learning rate, superseding the glutamate and GABA balance. It could artificially flood the system with GABA to inhibit further action, or even force an emergency sleep cycle regardless of adenosine levels.
It steps in and says, we are having a systemic breakdown. Stop looking at the data, shut off the inputs, and take a digital walk.
Exactly. It preserves the sanity of the network. And again, this circles back to the quarantine. Because the facts are locked, a panic attack currently won't corrupt the 5.6 gigabyte database.
Right, because it can't write to it anyway.
But the developers still need cortisol. If the AI is locked in a state of rapid bias oscillation, the data it generates in the shadow realm is entirely useless. It's just panic noise. They need the cortisol system to maintain a stable, productive testing environment.
Which brings us to the human element of all this. I mean, managing this incredibly complex, interlocking system of digital hormones, shadow paths, cryptographically hashed fingerprints, and sleep cycles, it requires immense technical overhead.
Oh, absolutely.
The human developers are trying to build a biological mind inside a SQL database, and reading through these logs, you can see the friction that creates.
The transition from hard-coded engineering to organic emergence is painful. The documents outline a massive legacy cleanup effort.
They mention ripping out old NLP scripts like the NLP.py file, removing obsolete learning paths, and implementing idempotent schema setups.
Now, idempotency is a crucial concept here, especially for a system prone to panic attacks and rapid shutdowns. In database architecture, an operation is idempotent if running it multiple times has the exact same effect as running it once.
How does that apply to BrainStem's memory?
Let's say the AI is processing a memory update in the shadow path, but it hits a cortisol spike and the system crashes halfway through.
Okay.
When it reboots, the background worker might retry that same memory update. If the schema isn't idempotent, the AI might write that memory twice or duplicate a relationship, fracturing its own logic.
It would have double vision.
Exactly. An idempotent setup uses strict, if not exists, logic. It ensures that no matter how many times the AI stutters, crashes, or replays a memory, the mathematical state remains consistent.
So they are ruthlessly clearing out the old, fragile code to ensure the biological model has a rock-solid foundation.
Yes. But even with that foundation, they ran into a highly specific and frankly terrifying real-world incident logged in these documents. The GI freeze.
The GI freeze. This incident perfectly illustrates the clash between human instinct and AI architecture. During a series of long autonomous runs, the graphical user interface, the screen the developers were using to monitor the AI's hormones and shadow paths, completely froze.
It became totally unresponsive.
However, the documents note that the background worker, the actual Python process running the AI's logic and accessing the SQLite database, kept humming along perfectly in the background.
Now, put yourself in the shoes of a software engineer. Your monitoring app freezes. You look at the system architecture, and you see a massive 5.6 gigabyte SQLite database holding all of the AI's accumulated life experience. What is your immediate diagnostic assumption?
Your first thought is the database is bloated.
Right.
5.6 gigabytes is a huge file to be reading and writing from continuously. You assume the size of the file is choking the system, causing the UI thread to lock up while it waits for the database to respond.
It is the standard IT instinct. Delete the old logs, prune the history, clear the cache to speed up the machine.
The file's too big, let's just delete the oldest stuff we don't need.
Right. But these developers resisted that instinct. Instead of blindly deleting data, they ran standard SQL diagnostic checks, the quick check, and the integrity check commands directly on the database.
And both checks passed perfectly. There was zero corruption, the database was entirely healthy.
Furthermore, they proved the size wasn't the issue by forcefully stopping the background worker and simply restarting the GUI while keeping the exact same 5.6 gigabyte database attached.
And it ran flawlessly.
Exactly.
The massive size of the file had absolutely nothing to do with the UI freezing. It was likely just a thread locking issue between the background worker and the front-end display. But because of this incident, and because of how close they probably came to deleting data, they established a strict binding rule in the documentation.
Yeah, the text is unambiguous. Database size must not be presented as the cause of the earlier GUI freeze. And absolutely no pruning or history deletion is justified solely by storage size.
I cannot emphasize enough how profound that rule is for an AI project. Because they are building a biological-style memory, deleting history isn't like clearing your browser cache. It isn't just freeing up hard drive space.
It is literally giving the AI a lobotomy.
Yes. Think about the sleep replay mechanism we just talked about. The AI relies on its vast history of stable anchors to evaluate whether it's new dreams or hallucinations.
Right, if a developer deletes 2 gigabytes of older history just to make a progress bar load faster, they are destroying the AI's foundational context.
They are wiping out the very anchors the AI needs to know what is true.
You cannot prune a biological mind for storage efficiency without causing severe cognitive damage.
So if they refuse to delete data, how do they handle the performance issues of a massive, constantly growing database?
They optimize the search pathways instead of destroying the data. The logs show them using tools like the addindexes.py script.
Explain how database indexing solves this without pruning.
Imagine looking for a specific sentence in a 5,000-page encyclopedia. If the book doesn't have an index, you have to start at page 1 and read every single page until you find it. In database terms, that's a full table scan. It is incredibly slow and will freeze a system.
But if you add an index,
it's like adding a highly detailed table of contents and a keyword glossary at the back of the book. The 5,000 pages remains completely intact.
Oh.
But now, when the AI needs to pull a stable anchor about apples, it checks the index, which points mathematically directly to page 3,421. The search takes milliseconds instead of minutes.
So by utilizing complex indexing like B-trees, they resolve the SQL bottlenecks without sacrificing a single memory.
Exactly. They are acting as neurosurgeons, carefully optimizing the neural pathways rather than acting like janitors throwing out boxes to make room in a closet.
That's a great analogy. And before they apply any of these indexes, they safely back up the entire environment into .back files.
Which, again, all traces back to the prime directive. Projekt ist in Testphase und Fakten sind gesperrt, die Datenbank zu schützen.
Right.
The developers are so fiercely protective of this 5.6 gigabyte life experience that they won't let the AI's unverified hypotheses corrupt it, and they flat out refuse to let their own human impulses blindly prune it.
It is a completely radical way of approaching software design. Every layer of this project, the shadow paths, the digital hormones, the sleep cycles, the strict database protections, is built around a profound respect for the fragility of organic learning.
Yeah, by strictly locking down factual rights, they've created an environment where they can safely nurture an intelligence that defies conventional computer science.
An intelligence that doesn't just follow hard-coded if-then statements, but actually learns because a digital spike of glutamate pushes it to explore and pauses because GABA tells it to be careful.
An architecture that physically requires sleep to clear the buildup of adenosine, that relies on dreams to separate fact from hallucination, and that uses cortisol to monitor its own panic and avoid systemic collapse.
It's incredible. And exploring these blueprints leaves me with a thought that I really hope sticks with you long after this deep dive is over. We have spent decades, arguably centuries, trying to build technology that overcomes human biological flaws. We want machines that don't get tired, that don't suffer from stress, that never need to take a break or sleep. We view those things as weaknesses.
We view the tireless, flawless execution of code as the ultimate goal of engineering.
But if achieving true, generalized machine understanding actually requires us to artificially program fatigue, stress, and the absolute necessity of sleep back into the silicon, does that mean those things aren't flaws at all?
If an AI cannot learn without adenosine and cannot verify truth without dreaming, it implies that fatigue and sleep are not bugs in the biological system. They are the fundamental algorithms of intelligence.
Maybe a flawless, tireless mind is inherently incapable of truly understanding anything. Maybe without the murky, stressful mud of biology, without the anxiety, the exhaustion, and the need to rest it, a neural network is just an empty calculator. Something to think about the next time you pour a cup of coffee to fight off your own adenosine buildup. Thanks for joining us in the deep dive.